looks like NanoHub is back. I don't know if it was the Amazon web server on Monday. Ooh, not that one. But we got our Jupyter notebooks back. Cool. Morning. So anything coming up so far for Module 3? Last time, on Monday, like server was down, so I just kind of walked through one of the Euler integration. Like if you kind of get this and like how to code it, all the other integration methods for computational kind of integrate, like solving differential equations, they're all the same. Like it's all stepping through time. The only difference is like how accurate do you want each step to be, even with larger time steps. So you can make better approximations or add and subtract different ones, but it all kind of works out to the same thing. I paused here? I paused. That's what I was talking about, the spoiler step. Yeah, and the newest thing for this module is that we're not just looking at like first order differential equations. These can be it could be like lots of coupled second order, third order, fourth order differential equations. Most physics is second order. F equals ma. A is a second order derivative. So most of the time we'll end up with like some kind of second order derivative, but maybe there will be multiple moving parts or other variables that we might care about. Nothing yet. Morning. All right, I'll check in, see what's coming up, like what everybody's working on, and then come back, do either demos or kind of troubleshooting. Yes. Yeah, that one, that wasn't Monday, that was last Friday. I walked through how to load in reading number 1. Okay. That was kind of a tutorial on how to do image correlation, like manual image correlation. And then you have a data set with like X, Y, and Z. Okay. Okay. Yeah. Okay, yeah. But Monday, like, no questions from...
No, I was confused about the index, but I think I got it.
Okay.
Yeah.
Yeah. Yeah, yeah, that's kind of index 0 is the first one. Yeah.
And I always have... Is that the same thing? Like sometimes in like somewhere that always exists.
Function itself.
But like you know how in the last one, you know like that
Yeah.
like I guess how do you tell what it includes? Like when you say like I don't have the like to describe it.
Okay,
Which is
yeah.
the problem. But like let's say if you want to put a histogram, right? And there's all those things that you put in a parentheses.
Yeah.
To like make the histogram how it needs to be.
Yeah.
How do you tell what like can you like make it give you a list of what you can change?
Yeah, so like specifically with histogram, the function is called PLT, and then you write that and put a question mark and it prints out what are all the options to change, like what you want to do.
So then that was gradually.
And that would be for every like function. You can try it for variables and some, because like yeah, this is like the Python sort of object oriented. Everything's an object. So it's kind of like think of like a function. It's like an object that stores in cells, parentheses, inputs versus an array is an object that contains brackets, index. So whenever you ask for like what is this thing, sometimes it will tell you, oh, it's an array. Here's some information about it. But most of the time, it's just other ones that have like actual documentation.
So then if you put in there what's from is it the order of what's fine or
Most of the time, it's not. The only difference with that is that like if you have required inputs, like for history, you have to give it some type of like usually an array. You give it some data. That has to be first. And then after that, you say it equals 12. Whatever input you want to mix and match of what required has to come first. And you don't specify like X equals, then you don't have to put the orders that other functions might set. Yeah.
I think it's just I have to look them up after and like this one, like what is this mean? What does that mean? How do I find out?
Oh, that one. It's due. Really, I couldn't bring the to just 15, but because it's a second input, it's assuming talking about the number.
And then if you don't, then it just is
Yeah, and I think the default is but it says none. I don't know how to find it out.
but then it's just
Yeah, so as you scroll down, so parameters are just and now it gives you too much information. Yeah, that's the problem with it. But the first time well, yeah, you're like, I'll never use that. But then as you use it more, or as you're like using functions more, man, I wish there was a way to figure out that. Yeah. That might be worth thinking about. So that one was like an actual video. So in navigating the part of reading, that one's kind of a tutorial. Yeah. So if you go through that one thing at a time, I think it was Friday, Charlie was just at something like that too. But I think on Friday we did like step by step. You did a fit between X and Y. Instead of like X and T and Y as a, so that one's like the half, the graph of the guys. So when you calculate it with your red finger, you can have this change in slope of that half. Yeah, so it's like a centimeter per centimeter squared. Yeah, yeah. That just yeah, you just put a T there. It should be, or that's the N, and then so T, X would give you very small, because that takes up much of the X. Yeah. Which should be like pretty small. Like if you do it once, you'll have like. Okay. I was sure if there's like a different place that it was supposed to like. Yeah, you can do that, and then you can save it wherever you want. So save it in your current folder, and that's where it will be. It's for this specific. Same footing, just trying to. Okay, yeah.
I'm just starting on homework.
Okay.
I've been distracted with the other classes.
Yes, yeah. This is like crunch time.
Yeah.
All right, so first thing that's coming up is like question number 1. Trying to load this projectile coordinates, like where does that file come from? And there's a part, this first reading is a tutorial on how to create and save that file. You can save it wherever you want, like inside your little like cloud server here. And I'm trying to remember, I think it was Friday when we went over let's see, a day ago, 4 days ago, 4 days, or it must not have been Friday. Maybe it was last Wednesday. I know it's weird to watch YouTube within YouTube. Nope. Here it is. Yeah. So in this video from 7 days ago, so 1 week ago, we looked at like step by step how to go through this video. The gist of it is that you want to figure out when you're tracking motion, how big is 1 pixel? Like how far do you move if you're moving 1 pixel inside this picture? And then from there you can capture all your mouse clicks, and because you know that whatever 10 pixels is 10 centimeters is 50 something pixels, and you know every time you move 50 pixels, as you capture that, you have that data saved there. I'm kind of fast forwarding, and I'm doing the same thing, mini-me also. So that was last week, going through that. It's there. Other one is that other thing that came up is we were just talking about like when we make a plot, or we're trying to use some kind of, in this case, like I have a plot, like, oh, but it's not the way that I want it to look like. I want something different. What are all the options that I can use for that? So if I want to know like how different this thing can be, I can write plt.plot and put a question mark, and that question mark is going to print out with the doc string. Like in homework 1, we were writing doc strings for functions, and the reason we were doing that is so that we kind of knew like what is a doc string, like why is it there, what is it supposed to do. And now you have like a little more Python experience. Some of this stuff probably makes a lot more sense because you've been using Python now for 8 weeks. Is this week 8? Maybe, I don't know. Time is relative. Time is an illusion. But so anyway, I pull up this plt.plot and it tells me, let's walk through like some of this stuff. If it's in brackets, brackets means that's optional. So you can plot something with just y, like just the independent thing, and it'll just be indexed. So it'll go from 0 to whatever the length of y is. So that's what that the bracket doesn't mean put it in brackets, it just means like you don't have to add it. If it's something like this, like a y, that one's a required argument, so you have to put something in there. You can't just say like plt.plot with no input. This fmt, again, these are like, they're optional arguments. And then data equals none, that's like you can add a data equals thing. And a lot of this doesn't, it's kind of like, well, I don't know what this is talking about. So we can scroll down and look at, so here's some different examples, another example. The line that says parameters, so every function will have something that tells you what parameters are. That's telling us like, all right, we need that y coordinate, we need those y inputs, like what are the things we want to plot. We can give it x things, so instead of going by index, we can go xy. fmt is, now we kind of see that this is a string, and you can specify like, is it a square or a circle, or is it a red circle, RO, like all these kind of parameters. And then what is data? I don't know this one. OBJ, an object with labeled data. I've never used this, the data option. I've never even seen someone use it. It seems like it would be cool, like if you had a labeled object, whatever, like X coordinates and velocities, I think it would keep track and then actually automatically label your axes, something like that. But again, I've never used it, never even tried it. Learn something new every day. And then there's all these, like down here, tons of other parameters that we can plug in there. Labels and line width and all sorts of stuff. Anyway, cool. Oh, and then we were looking at, all right. Let's do this. Squares. So when I went through reading one, I clicked on where the ball was in every spot. I converted those pixels to actual centimeters, so now I know like how many meters this thing is moving. It started, at least in the picture, negative 0.2 meters, and then went down to like negative 1.1 meters, and then started at 0.6 meters and went to 1.7. The values don't really matter, like the actual height, because it's just talking about like in the picture how far did it move. If it's at 0, 0, you're up in the top corner of the picture and top left corner of the picture. It's fine. So now what we're going to do in this first part of like is instead of taking derivatives, we'll fit a function and then take derivatives of that function. This is usually if you know something about, like if you have some physical insight into what you're trying to like find derivatives of, it always makes more sense to fit a function and do derivatives of like an actual polynomial rather than finding like, yeah, let's just look at it. I'll show you. So this is time versus y. So what I could do is say, take the diff of y, divide by the diff of time, and try to plot that. It gives me an error. Why did it give me an error? What happened there? One's bigger than the other. Why is one bigger than the other? Which one do we think is bigger? Time or my derivative, my diff? Time is bigger. Why is the diff smaller? It's only smaller by 1, 27 and 26. Because what? No, at least not in this case.
Oh,
yeah.
It's because of you have to have the base to subtract from. So everything's relative to a base. It's all the absolute. I don't know how to use words for that.
Yeah,
I can see the map.
Okay, yeah. Yeah, on the right track. Something about that, like, difference. Yeah, every difference has a pair. So, like, slope 1 is kind of like 0 and 1. Slope 2 is 1 and 2. But by the end, whatever, let's say there's 10 values, you have to do 9 and 10. There's no 10 and 11. The 11's gone. Yeah, so every time we use a diff, and it's literally just a difference. Like, it's not doing a derivative. It's not a differential. It's just taking the difference between numbers. So I have to make a choice. Am I starting at time 0 or time 1? And kind of 6 of one, half dozen the other. I'll choose time 1. If I take a derivative, there was noise, it increased the noise. Now there's more. Like now it's real wobbly. But if I want slope, if I want the slope of the slope, like to get acceleration, I need another derivative on top of this. So I have to do it again. So let's call this I get another error because now I can't, again, I lost another one, so I have to start. I could start here at like time 2. Or I could go like 1 to -1, right? -2. All right, we'll just start at 2. What? What's your problem? Oh, yeah. Oh my God. That was dumb. I can't even use that diff of t. I have to shorten that one, right? There we go. So if I'm trying to take that derivative again, I gotta use just 1 to the end. I gotta shorten that 1 value a little bit. All right, so now I've got my acceleration. Is that real? Is it really changing from -60 meters per second squared to a positive 25 meters per second squared? Or is it possible that I'm just not very good at clicking on a picture? That's probably the more, because we're looking at a double derivative of mouse clicks. It's like there's definitely going to introduce some noise. So instead of doing all that, we could say we'll call it like CY. At least I think it's going to be some kind of second order polynomial. Maybe it'll be a little higher, but probably second order will capture all the information I need. And this is like red polynomial going through the best fit red polynomial through all of my clicks to try to track the motion of this tennis ball. This looks pretty good. And now I could even compare it to let's just call it CY bracket 0. And my second derivative of this red polynomial is a flat line, because if I take two derivatives of a parabola, it's got to be a constant. And that looks like a pretty good approximation for all that noise that's kind of bouncing around it. Sure enough, if we took the average, it's probably the same number, but favorite item at McDonald's? I haven't been to McDonald's in, how old am I? 16. I haven't been to McDonald's in 24, 25 years. Yeah.
Also, like, the check that, like, the concept is about -9.8.
It should be around 9.8, yeah, and we can double check. 2 times C bracket 0. Oh, CY, sorry. I got -10, which is not bad. Again, we're dealing with like mouse clicks. We got our core group here, Krishna. Thanks for joining. All right, let's see like what else we're up to. All right, let's look at, a lot of us are kind of working on like how to get that first data, like how do we even get to that data? So let's take a look. I won't go through the whole thing, but I'll show like the main, so main thing is like, at least if you haven't done anything, just make sure you're starting from a blank slate. So I know I'm starting from scratch because when I ran this first cell, it says input 1. So I can keep running down, and I'm just doing one thing at a time, like one cell at a time, and stop and look at each output. All right, so this is where we have our first thing that we need to do, where we say coords equals bracket. That's going to clear whatever is inside coords, like whatever you clicked on. If you run the cell again, it's empty. All those coordinates are gone because it resets it back to an empty list. And then this onClick function, I'll pull that up and scroll back up to where that is. OnClick is a simple function that whatever that variable coords is, it'll append whatever your mouse click is into that coords variable. We could make this like more advanced, And if you want, you could do that, but there's also other ways of doing like image correlation. This is the most manual way. The kind of the cool way is like take a little subset of the ball and then do like a scrolling, like see what the maximum correlation is between the ball and your little image of the ball. But I didn't want to get into all of that because it's like a huge tangent to the work that we have been doing. Okay. Yeah.
We're running this on our own machine. I'm in there for image IO or image EO or whatever. It's not possible.
Oh, that one. So if you're running on your own machine, that image IO comes from, let's see. Yeah, right here. Oh, not that. So if you're running on your own machine, you might have to do, what you could do is it's called a bang operator or pip install, but I usually use conda. So you would run this command with like a bang operator, and it'll install that, and then it should. Sometimes you have to restart your kernel. Other times it just kind of works. But yeah, that's one of the. Usually that only happens if you're running like on your own Jupyter notebook, like server. All right, so now let's say I start clicking, click, 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 just a few of them, and so I have 4 clicks that I did in that image. But if I go back and rerun this, like, oh, let me try again, but I don't click on anything, now my coordinates are empty again. So that's usually what happens if you're kind of running through it quickly, but running things out of order. So instead, we gotta run this, click on just the 10 centimeter gap lines, and then down to 70 centimeters. So now I've got every 165, 218, 271, 326. The x coordinates don't really matter here, like we're just looking at how far the 10 centimeter pixel, y pixels go. And I can run these and find, at least on this quick one, I found that the average distance for 10 centimeters is 53.3. 53 1/3 pixels per 10 centimeters. Yeah.
So what do you do if it says that the file is not?
Files not found?
Is that something that I did now, or is it just like did I have to edit anything within the code to make it more specific on my laptop?
So the main thing, all right, so I'm gonna try this.
I did the install.
So this one, this is at least for this projectile cord. Like if you're trying to find this file, this is the line where you say save Z, because it's saving a NumPy array as a file in your server. So you can put it wherever you want. I think by default, it goes into the data folder. So if you're putting it in the data folder, then when you load it into homework, so I'll do that. I'll save it in the data folder. So now in the homework, I don't just load projectile coordinates. I go one folder up and then look at the data folder and then run that. And then it doesn't give me that error.
That is, I really get to that part. This is for like it can't even read the image.
That one, let me take a look, because there might be like a different roadblock that, but usually this is also like that was the other thing that I wanted to bring up is like wherever you put that file, it's gonna stay there and you can access it from wherever it is, but yeah.
I tried doing that with the fallen tennis ball data, and it said cannot load file with particular data and allow control is false.
Oh, with the falling tennis ball. I think falling tennis ball is, because I think that's this one. Sorry, I'm scrolling up and down trying to find this one, this falling tennis ball. So that one, so falling tennis ball, if you try just a load function, then it'll give you an error because it's actually just like a comma separated value. So you can use load text and that'll load it in. Also, another way to check is like use that head of so if I say like, all right, show me the first 10 lines, that's what that head command does. It shows me that it looks like this, versus if I try to do that with my what did I call it? Projectile chords. It's gonna give me a whole bunch of like stuff that a computer can read, but I can't read it. It's like binary sort of like stuff. And I probably don't even have the right like font files to actually display it on my computer. But that, I guess the one thing here is like, oh, I know it's NumPy. It has not a Fortran order. The shape is 26. So it has a little bit of information that I can kind of like pull out of this. But that head is a great way to kind of look at what am I trying to load in here. And then, yeah, load text versus load. Load is going to try to load in NumPy stuff. Load text is going to take text, turn it into NumPy. Let me check.
Are you down with it already? Okay.
So everything is
For some reason, that's the size I have. There's like a file in the same grade, right? Go back to the attribution. Yeah. I don't know why yours is like missing those files. So I think everybody has them.
Yeah, it's not, it happens with everyone,
Oh, in the next class. Okay, yeah, yeah. I didn't recognize you. I was like trying to check it. Okay, alright. That's cool. No, don't worry about it. Oh, that one is it's a binary NumPy file. So like when you take your NumPy array and say like, alright, save it on my computer. The computer knows what to do with that. I don't, yeah, it doesn't make any sense to me, but it's all. Yeah. But when you load, whenever you use like npm load, it'll just turn it back into like numbers. Okay. Yeah. So I have the data from the course. Yeah. But when you try it, how is it that we're going to be able to yeah. Like it, yeah, see that there. Another hour. I'm not it's there. It's the same thing. But then when I try to call it, put it across that, see how they yes, acquire all numbers that taken from your work. Yeah, now I'm starting. It will start. Yeah, first step, horizontally, is that something? At least by default, just down. 0, 10, 20, just work your way down. I mean, you could do either, you could go wherever you want. Yeah. But the only thing that gets checked is a thing called gap lines are the ones that go into that seven. So the second one, I mean, that one is grabbing like X and Y coordinates. Then we use that gap line to calculate fair. Say like 150 to 200 pixels is actually 3 centimeters. Oh, this is like the first one. Yeah, it's yeah, that like for the same like last week for senior design, that's an amazing tool because you can take a video or something and say like, all right, click, 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 and now here's whatever motion of this thing. You can get more advanced with that. The symmetry, particle movement, symmetry, how fast particles move.
Cool, making progress. Looks good so far. And then we'll be back on Monday. Sound good?
I think homework's due Thursday.
Due Thursday, and we just got started. I feel like we should push it off till Tuesday, at least have another day to work through and then debug on Monday. That's what I think. I think that would work. All right, thanks for letting me know. Cool, see you next time.